Looks like everyone is settled in.
All right, cool. So, hi everybody, I'm Brent Ozar, and tonight I'm going to be talking about why the same query is just sometimes slow. Man, I swear this has got to be the number one thing that I run into out on forums, people running into performance issues. And once you understand the basics of how this works, you're going to be so much better equipped to deal with performance problems going down the road. This will be weirdly hard. There are going to be things in there that you're going to write down, and then tomorrow morning you're going to go, I don't think I quite understood how that worked. So by all means, when you run into questions, go to brentozar.com, click contact up at the top, and feel free to ask us follow-up questions. Just make sure to say that you attended the user group webcast on Tuesday night, April 17th, because otherwise we get homework questions from people all day. Please design a database for classes and students. Like every university student who gets a college assignment seems to come to our site and wants us to do their homework. If you say that you were in the user group meeting, then we got all the time in the world for you. We just give people a reply back when they need to go do their college homework. With this, I'm going to teach you 4 things tonight. First, I'm going to teach you what parameter sniffing is. Second, I'm going to teach you how to react when it strikes. Third, I'm going to teach you how to test your code. And then fourth, I'm going to teach you several different ways to fix parameter sniffing. You're going to keep seeing me come back to this list of 4 things because it is kind of big. Everybody wants to jump straight to option recompile, and there's a whole lot of things you have to learn before you get there, and then you'll understand why option recompile usually doesn't work the way you want it to. So, in order to teach you what parameter sniffing is, I'm going to go pop into SQL Server. Here, you'll see that I'm using SQL Server 2017. You may have heard about the robots that are in 2017 that make DBAs go away, so to speak. Everything I'm going to show you is on 2017. It's not fixed. I'm in the latest compatibility level. This is the real deal. And I'm going to go into the Stack Overflow database, and I'm going to look at the users table. StackOverflow.com is a question and answer site where you can go post programming questions. Other people do the hard work for you, and then you take all the credit back at the office. The users table has exactly what you think it holds: a list of everyone who's either asked or answered a question over at Stack Overflow. In a Stack Overflow, reputation is very important. People are very competitive for points there. And everyone wants to know where they're at relative to everyone else. You get points for asking a good question, answering a good question, voting on things, all kinds of stuff. So I'm going to be querying on the reputation column. It's just an integer, just a simple number. I'm going to create an index on that reputation column and only on the reputation column. This doesn't cover the entire table. Reputation is the only field on it. And this table's a lot bigger. Table's organized by ID as the clustering keys. An identity field starts at 1 and goes up to a bajillion. So now what I'm going to do here is I'm going to go run, show me all of the users where reputation equals 1, ordered by their name. 1 point is the lowest amount of points that you can get a Stack Overflow. Everyone starts at 1 point. And so as a result, you saw that it took a minute. It takes like a good 5 seconds for this query to go and run, because there are a lot of people at Stack Overflow with only 1 reputation point. If I go look at the execution plan, SQL Server scanned the whole table. If I hover my mouse over that little arrow there, you'll see that SQL Server estimated that about 3 million rows would come back, and it's right. There are 5 million users at Stack Overflow overall. 3 million of them only have 1 point. It makes sense when you think about how Stack Overflow works, because the way that it works, everyone gets exactly 1 point when they sign up. And what most people want to do is that they go sign up for Stack Overflow, they post a question that they're very embarrassed to share. And so what they do is they create a burner account, like a throwaway account that they're never going to use again. They post a question with this burner account, they get the answer they want, and then they just disappear. And then they come back later, the next time that they want to go ask another question, and they post another question under a new account. They just keep creating throwaway accounts over and over again. So as a result, out of the 5 million rows, 3 million of them only have one reputation point. So SQL Server doesn't even bother using the index on reputation. It goes, dude, if you want all of the fields, you want the top 10,000 star, and you wanted them sorted by display name, this reputation index, this isn't going to do me much good. So it decides to scan the entire table instead of doing a bunch of index seeks plus key lookups. This makes sense. When I'm dealing with 3 million rows, it's going to take SQL Server a lot of time in order to sort that data if I want them all sorted by display name. So this is a big query demanding big data, 20 seconds worth of CPU. And it scans the entire users table, doing about 80,000 reads. SQL Server stores this kind of data in 8K pages, so I'm reading about 80,000 8K pages. It's less than a gig. That's enough to fit up in my SQL Server's cache. It's not a terrible query, but sorting all 3 million of those people, that takes some serious work. And so SQL Server also sets aside a large memory grant in order to do this. The memory grant for this query is about 5 gigs. SQL Server says, dang, takes a lot of space to sort 3 million rows, so I better give you 5 gigs worth of RAM. Here you go sort all that data. This is a great query plan designed for large amounts of data. When I change that number, if I change reputation to a different number, I'm going to get a different plan. What happens if I say, show me the top 10,000 users where reputation equals 2 points? It's very common for users to only have 1 point at Stack Overflow. It's very, very, very rare for them to only have 2 points. Because if you're going to do something to get yourself 1 extra point, you're probably going to keep going. You're probably going to keep earning points one after the other. So this query has a very different plan. This query decides to do an index seek because SQL Server says, oh, when I look for reputation equals 2, there's only 5,000 rows that match. That's hardly any people at all. So I'll go use the index, look up those 5,000 people who have a reputation equals 2 points. I can find them very quickly. It will be a short list. Then I will turn around and do a bunch of key lookups because he has to do the key lookups in order to get all this other stuff that my users are asking for. I do wish that execution plans were kind of three-dimensional. I wish they popped off the page in terms of the number of times something was done. Because when we look at that key lookup, we're just like, it's a key lookup. How bad could it be? Well, if you hover your mouse over it, look at estimated number of executions and an actual number of executions as well. SQL Server did this 5,000 times. So it wasn't that lightweight. Think of it as a phone book. If you had to go look someone up in order to get their phone number, if you had to look up 5,305 of your friends, you would read a lot of 8K pages in order to look up 5,000 different people. But it might be faster than scanning the whole table, and it is. Here, when we do the seek plus a key lookup, SQL Server reads less pages. As a reminder, when it did reputation equals 1 and scanned the whole entire table, it read 80,000 pages. Here it's reading 16,000, which is less. And the query runs faster because it just takes less time to sort 5,000 people. If all you have to do is sort 5,000 people, it's really not that hard. Here's what your execution plan looks like. I do my sort, but I'm only sorting 5,000 rows. Wait a minute, Brent. What's that yellow bang on the query? Yellow bangs are usually wrong, right? That means a bad thing on the query. Warning, SQL Server detected excessive grant. I gave you way too much memory. Oh, go on, SQL Server. How much memory did you give me? I gave you 29 megabytes. What? 29 megabytes? SQL Server carried? Didn't you just a second ago give me 5 gigs? You gave me 5 gigs of RAM a second ago and you didn't complain? That was different. Here, I gave you 29 megabytes and you only used 1. You left 28 megabytes on the floor. That's bad. I should warn you. How much did I leave last time, SQL Server? When I did reputation equals 1 and you awarded me 5 gigs, how much did I leave on the floor that time? I don't give you a warning there. It's not really a problem. You shouldn't concern yourself with that. I'm going to drill a little deeper. I'm going to go look into properties. SQL Server, how much did you grant me? 5 gigs. How much did I actually use? Less than 1 gig? SQL Server, I just left 4 gigs on the floor. Yeah, I know. Math is hard. It really should be giving me the yellow bang here. I'm leaving tons of memory on the floor. You know how some of y'all watch page life expectancy. You watch this page life expectancy counter and it looks like a sawtooth. It goes up, 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 down, up, 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 down. Well, when it goes down, people think that it's a big ugly query that's reading lots of data from disk. And it can be. But it can also be like this. Every time this query runs, 4 gigs of stuff disappears. This is data that I can't use to store anything else. My page life expectancy just bloop, drops. And when you go to look in your monitoring tool for long-running queries, there isn't one, because no query ran that long. I guess SQL Server is just not that concerned about that. Well, so I have a problem here. I have one query that produces 2 different execution plans, depending on what kind of number I pass in. If I use reputation equals 1 as a literal, I get the big plan. If I use reputation 2 as a literal, I get the tiny plan. Look at these 2 execution plans back to back. This is the big plan that's designed for 3 million rows to come back. Here's the small plan designed for 5,000 rows to come back. Now, right now, if everybody passes in their own queries as strings, the small one always runs quick. No one ever complains about the small one. On the bigger one, when I do it for reputation equals 1, right now it takes about 5 seconds. My users aren't happy with that, but they'll deal with it. 5 seconds is like their worst case scenario. So now let's do something different though. Let's put it into a stored procedure. I'm going to take the exact same query. Here's the query that we were looking at before. Go give me the top 10,000 from users where reputation equals something. Now, reputation is a parameter. So let's go make this stored procedure. And then let's go execute it. Now I'm first going to execute it for reputation equals 1. Remember, reputation equals 1 always took about 5 seconds. SQL Server builds an execution plan that scans the entire table, and he's happy with that. He's happy scanning the entire table, sorting the whole entire thing by display name, and he knows that it'll take him about 80,000 reads. Now I'm going to turn around and run the small query. And what you're thinking is that when I run it, it'll be slow. Nope, it's fast. It's really fast. It's, for all our purposes, as fast as it was before. And I know what you're thinking, well, maybe we get a plan designed for tiny amounts of data. Nope. We get a plan designed for large amounts of data. If I hover my mouse over what's coming out of that clustered index scan, SQL Server estimates that 3 million rows are going to come back every time the query runs, because the estimate is based on the first parameter that got passed in, not the most recent. So as I'm running this now over and over again, now SQL Server is starting to complain a little. Oh, dude, no, seriously. Before I was complaining about like 20 megabytes wasted, but now, oh man, I'm actually wasting 5 gigs. Who cares? It's fast, right? As long as the query runs fast, my users never complain. Well, now is when you see that page life expectancy looking like a roller coaster, because every time this instantaneous query runs, poof, there goes 5 gigs worth of your data that you could be caching for other things. No one's going to complain about this. Even though it's reading the whole table, this is technically parameter sniffing, but this isn't what gets people on the phone yelling and angry. Imagine for a second, though, that someone restarts the server, someone rebuilds an index, someone runs, heaven forbid, DBCC free proc cache. After I clear the cache, if I go through and run it for reputation equals 2, now I get an execution plan that is designed for tiny amounts of data, and SQL Server expects that only 5,300 rows are going to come back. And here's my friend Clippy. Oh my God, I gave you way too much RAM, 29, 28 megabytes, that's crazy, that's a huge problem, you're leaving 27 megabytes on the floor. And I'm only doing a tiny amount of logical reads, 16,000, or out. But now that the small plan is in memory, guess what happens when I run the big query? The big query uses the tiny plan, and now we're past 5 seconds, now we're past 10 seconds, now we're coming up on 15 seconds, now we're coming up on 20 seconds. Now my users are pissed. Now my users are angry, because this query that used to take 5 seconds is now taking 20 seconds. Because he got an execution plan that was designed for tiny amounts of data. If I hover my mouse over what's coming out of here, SQL Server still stubbornly thinks that 5,000 rows will come out every time I run this query, and it underestimates how much memory I'm going to get from my memory grant. Now Clippy's not laughing anymore. Now he's not complaining about this. Oh my God, I gave you way too much RAM of 29 megabytes. Now he's like, oh, sweet potato, I had to write 42,000 8K pages to disk. Because it's like a data tsunami that's coming through. SQL Server had no idea what was going to come through to that operator, and it just keeps underestimating how much memory it's going to give every time. Sometimes you'll see out there, bloggers will talk about, oh my God, DBAs are going away, they're being completely automated by the robots. The robots are not that smart. You can pull this query off all day long, and SQL Server's still like, I have no idea what I'm supposed to do here. I guess I'll go ahead and do these index seeks plus these key lookups and take 20 seconds. It's not even on the robot's horizon to choose a better plan for this particular query. Now, when I look at this, when it finally finishes, yeah, part of it was 20 seconds is a big deal. Yeah, part of it is that we wrote to disk. But you remember how many 8K pages were involved in our table scan? When we scanned the entire table, it was 80,000 pages. Now look at how many logical reads I'm doing. It was 80,000. I got to put the comments or commas in here just to drive home that point. We're now reading over 10 million pages every time this query runs. It's like SQL Server scanning the whole table over and over again. It's not what it's doing mechanically. What it's doing mechanically is, remember how I said you're going to go look up your buddies in the phone book? You're going to go do these key lookups? Hover your mouse over that key lookup. SQL Server's estimated number of executions? 5,000. Well, you're going to have to do this 5,000 times. You ran the stored procedure with a parameter of 2, so 5,000 people is all I should ever expect. And then it's doing 3 million key lookups every time this thing runs. That's where the tens of millions of logical reads start to come from. This is parameter sniffing. When SQL Server gets a plan that is catastrophically bad, even though nothing's changed, they didn't change the stored procedure, it's still the same data, nobody's doing inserts, updates, and deletes in here, it's just the random luck of whatever parameter happens to come in first. You restart the SQL Server, you patch it, you do a failover in a cluster, and whatever one happens to run first, that's the plan the SQL Server is going to ride or die with. Now, I told you that I was going to teach you 4 things. I told you that I was going to teach you what parameter sniffing is, was the first one. Second, I'm going to teach you how to react when the emergency strikes. When you're young in your career, the first thing that you go do is you go restart the SQL Server. And it works. But the reason why it works is because what happens immediately after you restart it is you go run the query that used to suck. Oh my God, I was running it for reputation equals 1 and it was timing out. All right, let's restart the server. Okay, I'm going to run it with reputation equals 1. Oh, it's fast now. Well, I guess SQL Server's got some kind of memory leak. It just needs a restart now and then. No, you gave it amnesia. It's like going drinking tequila all night in order to forget your ex-wife. It's not really the most efficient way to go about doing that kind of thing. As you learn later on, you start to do things like DBCC free proc cache, which has the same effect, but you're clearing the plans, all of them in memory. Now you're risking parameter sniffing for every query that you have. Then people start to do rebuilds of their indexes or updating statistics. And they'll think that parameter sniffing and updating stats are somehow related, but they're not. It's just that SQL Server wipes plans from the cache when an index is rebuilt or statistics are updated that are involved in that plan. SQL Server says, oh, we've changed those indexes. It's time for us to recalculate that plan. But then it just takes whatever random plan or random set of parameters happen to come in next, and that's the parameter set that you're getting for the plan execution. That's crappy. That's a gamble. Even worse, when you rebuild indexes or update statistics, you're wiping out all kinds of queries from the plan cache, not just the one that's having the problems. So the way better way to do this, the way the professionals do it, is they just get one plan out of the cache. They find the one query plan that's having problems and go into a targeted strike to just get one of those out of the cache. The tool that we use in order to do that is totally open source, it's totally free, you can go download it, Google for SP Blitz Cache. And when I run it, let me show you how it works. So I'm going to pop open a new window and run SP Blitz Cache. I'm going to use it with expert mode turned on, because expert mode gives me something cool that I'm going to show you here in a minute. When I run SP Blitz Cache, it gives me a list of the top 10 most resource-intensive queries on my system, plus it also gives me problems that are involved in those queries. This is not a query tuning class, so I'm going to avoid the stuff on the bottom for right now, and I'm going to focus on the stuff up on the top. This is your leaderboard of the worst performing queries, except obviously these aren't leaders, these are terrible queries. When you run this out on yours, you're going to see your worst enemies in terms of queries up here. So instead of calling it the leaderboard, I call it the sucker board, because these are the queries that suck the absolute worst. When you run SP Blitz Cache during a performance emergency, what you're looking at on this list is, do I recognize all of these queries, or is there one on the list that's not usually on the list? Is there one that I look at and I go, yeah, I know this one, I know this one. Wait, what? Users by reputation, he's never on the sucker board. What's he doing on the sucker board? And if I look over at the warnings over here, you notice how it shows parameter sniffing? I wish I could tell you that we're doing some kind of advanced diagnostics to tell you that, yes, this is a parameter sniffing problem. But all we're really doing is we're looking for queries that sometimes take hardly any resources and sometimes take a spectacular amount of resources for exactly the same query. That's a classic fingerprint of parameter sniffing. It's just not always parameter sniffing. Because I bet some of you guys use Ola Holmgren's database backups, for example. Well, Holland has a stored procedure that'll go through new database backups, index rebuilds. Well, sometimes you back up tiny databases, and sometimes you back up large databases. You're using the exact same stored procedure, just with different parameters. That will also look like parameter sniffing. So it's not perfect. Just giving you a rough guidance there that we think this thing might have a parameter sniffing problem. What people are immediately always compelled to do is like, oh, let me go look at this code, let me go see if I can tune it. Not during the emergency, you don't. I gotta teach you 4 things. We're just on number 2, how you get past the emergency. In order to get past the emergency, I want to clear that plan from the cache, but before I do it, I want to save it. There's a query plan link over here. And if you click on it, you get the query plan for that stored procedure. I need to save this. This is so important in order to save. Because after the emergency, I want to fix it for good. I want to sit down and work with my developers and say, how are we going to make this stored procedure less vulnerable to parameter sniffing? Maybe we change indexes, maybe we put a hint in a query, maybe we use a plan guide, whatever. That part takes time. So in order to prep myself for that, what I'm going to do is save it. I'm going to say file save, and I'm going to say bad emergency 2018-04-17, parameter sniffing. And I don't know why it's bad yet. I just know that this is the query that I'm going to go and tune when I get to part 3. Right now, I got to get past the emergency. This guy's at the top of the sucker board. He's absolutely killing my server. So in order to make him go away, I'm going to scroll all the way to the right, and I have a dbcc free proc cache command that will just clear this one plan from the cache, or this one SQL statement. So what I can do now is copy-paste him out, paste him, and now I can run just this one free proc cache command. Any new queries that come in from this moment forward will get a new plan. Dude, I haven't fixed parameter sniffing. All I'm still doing is gambling. This is effectively just like restarting your server for this one query, or rebuilding the indexes for this one query. But what I do is I get on the phone with my users and go, okay, you know that query that was sucking, or that part of the website that was sucking, can you go in there again now? It's fast? You say it's fast now? Okay, all right. If it's fast, I'm past the emergency, and I can go start troubleshooting this query. If it's still slow, it may be because there's a lot of these queries that are up and running still. When I free the plan cache for this query, it's only freeing it for queries that come in from this point forward. It doesn't free it for queries that are already in flight. Any queries that are already in flight have to finish, or I have to kill them. I'm not a really big fan of killing queries, because killing queries is single-threaded. You can have an update statement that was working across 8 cores for an hour, pushing work forward. You go and kill it, you could be stuck in an 8-hour or longer rollback. So just make sure, before you go and kill queries in order to make the sniffing emergency go away, just make sure that they're not actually doing work. Because if they were doing work, you could be in trouble. But if I get off the phone with my users, I go, oh, okay, everything's fast now? Okay, all right, I found the problem. Now I'm on to number 3. I've told you I'm going to teach you 4 things. What sniffing is, you've seen that now in action in the form of this query that gets a horrible plan out of nowhere. Second, I've taught you how to get past it. You're going to use SP Blitz cache and then free just one specific plan from the cache. Now we're on to number 3. How do I test this query so that I can figure out if it really has a parameter sniffing problem and how I'm going to fix it? If I told you to run this query, I bet I know what most of you would do. Most of you would right-click in here and you would click Edit Query Text, or else you would go out and script the stored procedure. Editing the query text is a little bit of a shortcut. It doesn't always work. Sometimes it clips out a bunch of parts of the stored procedure. So you'll see me and a lot of presenters usually using edit query text. Just know there's a gotcha, and you could be missing parts of the stored procedure. I'm going to use it right now because you've seen that stored procedure, and you know this is the whole entire thing. So when I tell you that you've got to go through and run this, and then try to see a couple of different query plans for it, what most of us will go do is we'll just simply take out the create procedure part, take out the as part, and then we'll change this to a local variable. This way, now we can put in things like, go show me reputation equals 2, go build a query plan for it. Now when I hit query and include actual execution plan, this query is going to run fast, because of course this query is designed for tiny amounts of data. As you can see, I get the perfect execution plan for reputation equals 2. I get the index seek plus a key lookup. Now, I'm going to turn around and run it for reputation equals 1. I am taking a lot of time out of the process. We're on part number 3, which is testing your code. But what you might ask is, Brent, where did you get the numbers 2 and 1 from? Well, I had to go dig through the code or the plan. The plan gives me a little bit. If I look at the parameters on the plan, it'll show me what values built the plan, but it doesn't tell me what values have a problem with the plan. Like in our case, reputation equals 1 causes this thing to simply fall over. I wish there was a magic trick that would tell you what parameters have a problem with it. There isn't. This is left up to you to go figure out. But once you know those numbers, now you can run these back and forth and try to see whether or not they get different plans. Now remember, I do have to free the plan cache. You, I'm sure, would be doing this in a development environment, not in a production environment. But when I go test for parameter sniffing issues, I'm going to free the plan cache, and I'm going to do this a couple of times because it's very quick, and people are always like, Brent, you forgot to blow the plan cache. I am blowing the plan cache. You see me blowing the plan cache. Now I'm going to turn around and run it for reputation equals 1. When I run it for reputation equals 1, should get a different plan. Should get a plan designed for large amounts of data that expects 3 million rows back instead of 5,000. But we're past 5 seconds. We're past 10 seconds. We're past 15 seconds. Clearly, I didn't get the big plan. I got the tiny plan. I got the tiny plan designed for small amounts of data. This tiny plan did, well, I forgot to get statistics IO, did 10 million reads. And here's the interesting part. How many rows did he expect to come out? It's not 5,000. It's 314.7. It's kind of an unusual number. Let's go through and we're going to change this to 2. And I'm going to free the plan cache. I want you to see me doing it. I'm going to hit execute. Hiccups there. I'm going to hit execute several times on freeing the plan cache. It is freed. And now let's run it for reputation equals 2. And I get the seek plus a key lookup. And if I look at the number of rows it estimated 314.7. 314.7. Where did that number come from? Normally, when SQL Server is building query plans, it relies on statistics. Normally, it says, well, Brent, you have an index on reputation here, and I know that if you pass in a reputation equals 1, I can expect 3 million rows to come back. When you pass in a reputation equals 2, I can expect 5,000 rows to come back. This here is called the histogram in the statistics. Every index automatically gets a statistic created for it. You don't have to do anything special. This is how SQL Server understands when it should use an index and when it shouldn't. If you pass in reputation, it should not use the index because so many rows are going to come back. But if you pass in just reputation 2, it should use the index because so few rows are going to come back. But there's no 314.7 anywhere on here. Or is there? If you look really closely, if I take the number of rows in the object times this number right here, paste that out, and I get 314.7. What that magic number is, if I go back and show you the statistics again, what that magic number is, it's called the density vector. What it means is for the average reputation, if you just picked any number inside the histogram, the average reputation would have 314.7 people with that reputation. Whenever you use a local variable like this, SQL Server simply ignores the histogram and says, I'm going to optimize for the average reputation. It's kind of like SQL Server saying, oh, a local variable? Who could possibly know what the contents of that are? I'm going to guess the average. SQL Server, I'm telling you right here that the contents are 2. But that could change. It didn't. SQL Server doesn't change anywhere in the query. I don't know that. I have no way of knowing until runtime what that thing could possibly be. I better guess the average. And so what happens is people who are tuning their queries this way, they'll go, well, I tried for reputation equals 2, and I always get exactly a plan that looks like this. And when I try for reputation equals 450, I also always get a plan that looks like this, and then they'll monkey around inside the T-SQL. Maybe they'll create an index, or they'll throw a CTE on here, put a bird on it or something. They'll go, well, I must have solved the parameter sniffing problem. Yay me! Because now whatever I do, I always get the same plan. You're not even troubleshooting parameter sniffing. As soon as you have the local variable in there, it doesn't matter what numbers you put in. SQL Server is always going to pick the same plan. So it doesn't matter when you tune like this, you're not really fixing anything. If you want to fix parameter sniffing, you actually have to have parameters, and a local variable isn't a parameter. Now, people will usually say, well, Brent, I think you're telling me that I have to go create a stored procedure. Yes. But I'm not allowed to create stored procedures. If I try to do this over in production, if I do this kind of thing, even if I do like temp at the end, I'm going to get in trouble if I go create stored procedures and then go monkey around with the insides. And I can't make changes to those live in production. That's true, but you can do this. Just like you create temp tables, you can create temp stored procedures too. So if I go execute this, then I can go say exec USP, users by reputation equals 1, go. They work just like regular stored procedures. And now I get the 5-second plan. SQL Server goes through and does a clustered index scan and correctly estimates that 3 million rows come out. If you want to troubleshoot parameter sniffing, you have to have parameters, and local variables are not parameters. So you're going to have to either create a stored procedure or do dynamic SQL. Either of those will work with things like SQL execute SQL. Holy smokes. I said out of 4 things I'm going to teach you. I taught you what parameter sniffing is. I taught you what to do when it strikes. And now I'm teaching you how to test your code. I haven't even told you how to fix it. I'm just telling you how to test your code. That in order to test your code, you have to have real stored procedures. Now comes the next part, the fourth and final part. How are you going to fix this problem long term? When you want to go through and change your code, change your indexes, change the database, etc. The one that everyone always immediately wants to run towards is option recompile, and everyone knows that, oh, there must be some drawbacks with that, so maybe I'm going to wait to hear an option that's better, or I'm going to wait to hear an option that sucks less. all through when I'm teaching this in person, I see people literally holding their pen over the paper, waiting and going, oh, that one sucks. All right, what else you got? Okay, that one sucks. Yeah, no, what else have you got? Every option I'm about to show you sucks. They all suck for totally different reasons. It's just a matter of having a bunch of different tools in your toolbox and finding the right one that works for you. When you're looking through the tools in your toolbox to fix parameter sniffing, the first question that you have to ask is, can I get one execution plan that works well no matter what parameters I pass in? If I can do that, then all the options up at the top are available to me. That's not usually where people start. People start by going, well, I want to get a different execution plan for every single set of parameters that comes in. All right, that's the bottom set. And those have some kind of tricky gotchas. Option recompile is the one that most people go to first out of their toolbox. There's two ways that you can put option recompile on a stored procedure, on a query, whatever. One way is that you can put it on the entire stored procedure. The other way is that you can put it on lines inside the stored procedure. Never put it on the stored procedure. Never put it on the stored procedure. The reason why is that when you put it on the entire stored procedure as a whole, SQL Server has amnesia about the number of times the stored procedure was called, how many reads it did, how much CPU it did, all of that stuff. Plus, it has amnesia about everything inside. But if you put it on lines in the stored procedure, SQL Server does have amnesia about the number of times that this line was called, the amount of reads it did, the amount of CPU, etc. But it tracks the parent. It said that this entire stored procedure as a whole has been run 1,000 times. It's burned this much CPU time. It's just that we don't get visibility inside the stored procedure. And that's fine. At least with option recompile, I'll be able to track the stored procedure and see how much of an overhead he has overall. Now, option recompile gets you a fresh plan designed for every set of parameters that comes in. There is a CPU cost with that. The harder the SQL Server has to work in order to build these execution plans, the CPU on your box can go up. So where this makes a lot of sense is for queries that aren't called very often. If you have a query that's called, say, every minute or two, and to me that's not very often, because I deal with a lot of people who want to call things thousands of times per second. But if you run the query every minute or two, the compilation's usually not that bad. It happens in a few hundred milliseconds and you're out the door. That's the big first barrier. If the query isn't run that often, I'm okay with it. The second thing is, does the query show any private data? Does it show anything like healthcare data, social security numbers, credit cards, people's height, weight, whatever? If it does anything like that, you need to know about this bug that came out in 2008. And I'm going to break this bug for you down in plain English. You and I could be running the same stored procedure at the same time, but with different parameters. You might be looking at your bank balance, and I might be looking at my bank balance. And I could see your data, and you could see my data. It's a pretty serious bug. And of course, if someone came to you like that, if they came to you with a printed report, and they go, you know what, I ran this for a patient in Florida, but I'm seeing a patient in Michigan's information. You'd be like, yeah, put the crack pipe down. That's not how databases work. You probably picked the wrong thing in the search form. Go try it again. And they would try it again. They would never really trust you, and even worse if they'd seen private data. Notice that this hit in SQL Server 2008, and it took Microsoft a year to nail this down. Who could blame them? Because if you're Microsoft and somebody comes to you and says, hey, I ran a stored procedure for Texas and I'm seeing the last results, you'd be like, oh, come on, you suck as a customer. And at least that bug got fixed, right? And that'll surely never happen. Oh, it happened again! It happened exactly the same bug happened in SQL Server 2012. And this time it took them 2 years to patch it and nail it down. Because you just know that the people at help desk were like, listen, that was in 2008. We don't have that bug anymore. We fixed that. It's got to be user error. Come on. We won't ever do stuff like that. So I'm okay with option recompile if it's data that anybody else could see and the query doesn't happen that often. Because of course, if this bug has happened twice, it's happened two times. You know it's going to happen a third time. That's exactly how application stuff works. Nothing ever happens just exactly twice. It's more often than that. So that's the first option, which is option recompile. People hear that, they're like, oh my God, someone else could see someone else's data, especially if you're a software vendor and you know your customers are still running 2008, 2012. You're like, oh, I better, what else have you got for me? Right, so here's the next option that you could use to fix it. Inside my stored procedure, I could have a branch. I could say if reputation equals 1, go run this stored procedure. Otherwise, if reputation is anything else, go run this other stored procedure. And they do have to be separate stored procedures. They can't just be select statements, because all the selects get optimized at exactly the same time. These stored procedures, however, do not get compiled until they're executed. And when they're executed, they get sniffed. So users by reputation 1 will get sniffed, but he'll always get sniffed for a value of 1. Users by reputation other will also always get sniffed for, who knows? Maybe 2, 400, 67, 84, who knows? But as long as all those other values can live with the same plan, then this branching will work. If I had a list of values that might all need the top branch, then I might have to hard code that into my stored procedure as well. Here's the mind-blowing part. Both of those child stored procedures, reputation 1 and reputation other, they can have exactly the same select in them. They can be the same thing, just like copy-pasted, but they'll get different plans, each of which gets sniffed for their own custom values. This comes with a drawback, though, of technical debt. Because what you're essentially doing is hard-coding business logic into your stored procedure. What happens if tomorrow at Stack Overflow, they decide to change the starting point number? What if in order to make everyone feel better about themselves, instead of just giving one reputation, they start giving 10 reputation points? Oh, then I gotta go back and edit all my code. I gotta go to every stored procedure that has branching like this, and I gotta change that hard-coded list of values. That would suck. So because of that, this is a fairly rarely used trick. I can probably count on one finger per year, not that finger. I can count on one finger per year the number of times that I use this trick. It's pretty rare, but for exactly the right scenario, it helps because I can end up getting different execution plans for different values. I'm now past the two options I had that would give me different plans for every value. Now I'm into the list of things where I only get one execution plan, and it has to work for everyone. Maybe that density vector works for you. Like maybe in your case, you actually want to average for the average. You want to optimize for the average reputation. That's what this hint does. Optimize for unknown says, yeah. It doesn't matter what parameter comes in here. I'm just going to optimize for the average one, no matter what. This, in order to figure out if this makes sense for you, you have to go try your query plan with something like a local variable to figure out if it works, or specifically passing in a parameter that mimics the density vector's value. This doesn't work at all for me with the Stack Overflow case, because if I optimize for tiny amounts of data, I am screwed every time reputation equals 1 comes in. I'm going to end up doing those millions of key lookups, so this simply doesn't work. But it could make sense if the tiny plan in this case worked for your tuning scenario. This option, this way of fixing it, introduces the same results, but gets there a different way. This says, I'm going to use a local variable, just like we did with our testing. And when you set this local variable up, then you set the value to it to be the same as the outside reputation parameter in your stored procedure. You just use this local internal variable whenever you're calling queries. Flat up, never do this. Never, ever do this. Because when someone comes in behind you, you look like an idiot. People look at your queries and go, what kind of moron would go and set a local variable and then set the same contents out? That doesn't make any sense. And then the first thing that they do is comment all this out. They think it's left over from something else, somebody who didn't know what they were doing, and then they just use the outer reputation variable here. If you want to use the density vector, don't do this. Instead, do this, optimize for unknown. Because now, when people come in behind you, they go, oh my God, I've never seen anything like this. This is crazy. That last guy, he must have been a rocket surgeon. He knew everything. I've never seen that trick before in my life. And then they'll leave your code alone, and they won't touch it. Then you look good. That is a better option. Never, ever use a local variable trick. Next trick that you can use is to hard code in a specific value. So you could say option optimize for reputation equals 1. There's nothing built into SQL Server that's going to tell you what value you should use here. This is only when you know your data very well, just like our branching case. If I know that there's one specific value that produces the best execution plans for everybody, then I can hard code this in. But just like that branching trick, this means that I'm now embedding logic into my code. That if that value ever goes back and changes, like we change our starting reputation value, I'm going to come back and edit these stored procedures, which can suck. But the reason why this is more common than the branching trick is I still only have to maintain my query in one place. Whereas with the branching trick, I now have to update my T-SQL in two different places in case that select ever changes. Next trick that I can use is plan guides. Now, when execution plan guides first came out, they sounded really cool, but they were really hard to use. It was really hard to get SQL Server to match up a query with a query plan and keep it around for any length of time. They're becoming trendy again with the advent of Query Store in SQL Server 2016. Where Query Store in 2016, it works in every edition, works in Standard as well as Enterprise. They have this really nice dashboard, really nice as a stretch. They have a dashboard in Management Studio that will show you the executions over time for a query, and it'll let you simply right-click on an older query plan and say, I want to force this one all the time. Except it doesn't always work. And when it fails, it fails silently. If you say, I want to plan this, I want to stick this plan guide in, and I always want to use this execution plan no matter what, it might work today, but the instant that someone does index tuning behind you and drops an index out, or the instant that somebody changes this query at all, if they put one space in it, if they add a comment, anything, they go in and use a formatting tool, the query will simply no longer use the plan guide at all. I'm not saying you should use plan guides. I like plan guides, but I think of them as kind of like duct tape. I want to use them to get me past like a 48-hour emergency. If I can duct tape a plan guide fast to solve an urgent problem, but then I got to come back and build up a long-term plan with my developers to go, all right, this query over here, it's got a plan guide on it. Now I need to go to the app and make sure that whenever we change this query, that it always stays the same. My developers are like, screw you, you're talking to, we change things every week around here, we don't even have documentation. So I can't usually do that trick. I usually have to do something else in the T-SQL in order to get a better, more permanent fix. Then finally there's the really hard solution. And the really hard solution is to get one execution plan that works faster than it ever did before. Typically, the whole reason that we're here when we're looking at parameter sniffing is if I go through below the plan cache, we'll come back over to our main window. If I blow my plan cache, and then I go and run it for, say, reputation equals 1, takes about 5 seconds to run, and when it finishes, Clippy, your SQL Server, pops up and goes, Dude, he's not even doing it now. Oh, SQL Server, you're so crazy. Let's see, let's blow the plan cache. Stop. Blow the plan cache. Run it for reputation equals 2. Clippy, did you give me a missing index? You sure did. Clippy goes, hey dude, I really, if I had this index, things would be better for everybody. Go on, Clippy, tell me more. I'm going to right-click in here and say, show me the missing index details. I'm going to copy this out and show it to you right next to the query so that we can all laugh at Clippy together. Here's the stored procedure. Here's what Clippy wants. So we're saying, go give me the top 10,000 where reputation equals a number, and we want those 10,000 ordered by display name. Hey Clippy, what do you want your index to look like?
Well, I just want you to sort them by reputation. And then I would like you to include all of the other fields on the table.
Hey Clippy, that about me, he's a var max. You want him to?
Yep, I like it.
Clippy, can I ask you something? We only want the top 10,000 by display name. And when I run this with reputation equals 1, there are 3 million people, all with the same reputation. Are you sure you don't want to sort them by display name too, maybe? Are you sure you want that in the include?
Nope, trust me, I got this. What I'm going to do is every time you run the query, I'm going to sort them all by display name. I'm going to show off just how cool my $7,000 cores really are.
Sometimes I honestly think that Microsoft is like trolling us, like that they don't want to give us better missing index recommendations because they want our CPUs to be on fire. If I want the data ordered by display name, display name shouldn't be in the includes. It should be in the key. So screw Clippy. Here's what we're going to do. We're going to say index reputation display name, and then I'm going to only put display name up here, and I'm not going to do any of that other stuff. All I'm going to create the index on is just reputation and display name. This isn't perfect. This isn't a covering index. It's only going to satisfy part of my query. Let's see if SQL Server will use it. If I now go through and run, let's say, below the plan cache, and run it with reputation equals 2, Clippy says,
well, that's a great idea. An index on reputation and display name, I'd be glad to use that. But you know what I would really like? I would like an index just on reputation. I would seriously go over the missing index details. Seriously, I would love to sort the whole thing by display name every time it runs. Sounds like a great idea.
Missing index requests can actually make your query slower instead of faster. So you can get there, you just can't get there by looking at what Clippy says. This is where it takes extra time from a human being to go in and do a deeper level of index tuning. Can you get to where one covering index satisfies the query? Yeah, it's just harder. So for our demo query, for Stack Overflow, for the stored procedure, look at a little scorecard of how the different options would have worked. First off, option recompile. I would be totally fine with that if the query only ran, say, once every minute or two, and it's not like Stack Overflow database is private anyway. It's all entirely public. You can go download it. So I'm not really worried about security concerns. Option number two, stored procedure branching. That would totally work. I could have one branch for reputation equals 1 and another branch for reputation equals 2. It's more work on my part. It's more stored procedures I have to manage, but it would work. And then I would get plan reuse over and over again, whereas with option recompile, I don't. Further on down, optimize for unknown. This wouldn't help me at all. because it would estimate the tiny number of rows. SQL Server would end up doing millions of key lookups. I'm not saying that optimized for unknown is bad. There are times when it makes sense. All of these solutions suck for different cases at different times. Optimize for reputation equals 1. This would work great, but just know that I'm going to end up doing the table scan every time. Every query will be fast, but it won't use the indexes, and it'll end up with that giant 5 gig memory grant every time the query runs. Getting one good execution plan for everyone. I can't do Clippy's index, but if I worked a little harder, I could create my own index, just not a covering index, so that it'll be well enough that even reputation equals 1 will use it. And then finally a plan guide. A plan guide wouldn't work for me here because in things like a stored procedure, those queries are going to change all the time. It's not that I don't like plan guides, just that it wouldn't make much sense for this case when I have active developers. So today I taught you 4 things. I taught you what parameter sniffing is. Anytime you're using parameters, SQL Server can be vulnerable to choosing one branch, using one execution plan that may not be effective for all of the other ways that you might call a stored procedure. It'll change all the time based on things like the server restarting, indexes rebuilding, updating statistics. All of them can cause you to be more vulnerable to parameter sniffing. Number two, when emergencies strike, whenever you think that all of a sudden the same query is suddenly terribly slow, run SB Blitz Cache with expert mode turned on. If you see a query jumping to the top of the sucker board and you're like, man, this query's never terrible. Why all of a sudden is it so bad? Save the execution plan and then go do a targeted strike of just that one query from the plan cache. Third, when you go to test that query and tune it to make it less vulnerable to parameter sniffing, you can't use local variables. You have to create a stored procedure or use SB execute SQL in order to use real parameters to see parameter sniffing. Otherwise, you end up with the density vector and you're not tuning the same thing that people are actually facing. Finally, to fix the problem long term, you have stuff like option recompile, all kinds of optimize for specific variables, all of which have their own pros and cons. Now, we are right at the end of our session, and I know how this always works. People go in the next morning and go, oh my God, I have no idea what I should do in terms of what's going on with this particular stored procedure. What was it that he said about why option recompile is so bad? When you run into questions afterwards, just go to BrentOzar.com and click on Contact up at the top. Make sure to include that you were in the user group session tonight. Otherwise, you'll just get a form response back that says, hey, you should go post this on Stack Overflow. So thanks everybody for hanging out with me tonight. Are there any questions that y'all want to ask out loud?